Hello students, welcome to the part 2 of the chemical reactions of amines. In this video, I'll be discussing on the comparison of the basicity of primary, secondary and tertiary amines and with some conditions for the order of basicity. Now, the comparison of the basicity is based on three different theories. The first one is plus I effect. Now this plus I effect is applicable in the gas phase, as well as in the aqueous or liquid phase. It is applicable in the gas phase as well as in the liquid or the gas phase. Now we know that when the plus I effect increases, the basicity will also increase. Plus I effect increases means the basicity will also increase. Therefore, now see, let us check here. We have this is our primary amine. This is our secondary amine, and this is our tertiary amine. Now, the plus I effect. In the plus I effect, this pushes the electrons away from it, making the availability of the lone pair of electrons on nitrogen atom for donation. Now here is only one group pushing the electron toward. Here two groups are pushing here towards nitrogen. Here we have three alkyl groups pushing the electron towards the nitrogen atom. Therefore, the availability of the lone pairs on nitrogen atom would be more in tertiary than secondary than the primary. Therefore, the order of the basicity can be regarded. Here's that tertiary amine is more basic than secondary amine than primary amine. Now the second method is known as solvation. The theory of solvation is applicable only in the aqueous phase or the liquid phase. Now, solvation means solubility. Now, amines are soluble in water and they form cations easily. Therefore, amines, they are soluble in water. Therefore, next with the now takes away this, and then they form a cation. This forms a cation here. Now, the cation, since they are water soluble, they form cation easily. Now the cation, if this cation is stable, then we consider that this amine is a good base. But if this is unstable, then this would not. The basicity would be very less. Now stability. According to thermodynamics, we know that the more stable the molecule is, less energy is required. Now here the stability can be checked by how many water molecules can be attached to the amine molecule, to the cation of the amines. Now consider a primary amine. The cation of a primary amine. This is the cation. This is a primary. Now we have here. This is our secondary cation, and then our tertiary cation would be here. Our tertiary cation would be here. Now in this primary amines, here one water molecule, the second water molecule, and the third water molecule can be attached. Now in the secondary amines, only two water molecules can be attached. However, in the tertiary amine, only one water molecule can be attached. Therefore, we can say that since the stability is checked by how many water molecules can be added, therefore, we conclude here that primary amine is more basic than secondary amine and then tertiary amines. Now, third factor is the steric hindrance. Steric hindrance is also known as crowdiness. Suppose you are in a crowd of thousands of people. In order to cross over all of the people and reach your friend who is far from you, you need to push away all those crowds of people in the crowd to reach your friend, but it would take some time and you would require energy. Therefore, the crowdiness gives problem to electron can. Now in primary amines we have here, there is only one crowded bulky group, one crowded group. In the secondary amines we have here two crowded group, and then in the tertiary amines we have here three crowded groups. The three crowded groups in tertiary amines makes the electrons on the nitrogen atom less available. Therefore, the primary amine would be more basic than secondary amine than tertiary amine. Now, however, considering all these three theories, the basicity depends on the nature of the R group. Therefore, now let us discuss the nature of the R group in the order of the basicity. There are two conditions for the nature of the R group to determine the order of the basicity in amines. Now, the first condition is if R is an ethyl group. If R is an ethyl group. Now, experimentally, it is found that this is a very important point for our exam, so please note it down. Experimentally, we have here C2H5. Here is a secondary amine. A tertiary amine, since three ethyl groups are added, and then this is our primary amine. This is secondary, tertiary, and primary amine. It has been found that secondary amine is more basic than tertiary than primary. Now, the second group, second condition, if R is a methyl group. Now, CH3, the methyl group, this is a secondary amine, a primary amine, and then this is our tertiary amine. Now, experimentally, it is found that here also the secondary amine is more basic, but here the primary amine is in the second order, and then the tertiary amine is the least reactive one under the condition that R is a methyl group. Now, before going into discussion for this, let us check the theories. The first theory, in the plus I effect theory, we had the tertiary amine was more basic than secondary than the primary. In the solvation theory, the primary was more basic than secondary than tertiary, and in the third factor we had our steric factor, that is the primary was more basic than secondary was more basic than the tertiary amine. In all of the three theories, the secondary amines was in the middle of the second order was in the middle or in the order of the reactivity. Therefore, when we take the nature of the R group, the secondary amines is found experimentally. It is found that the secondary amines in both the cases, when R is an ethyl group and when R is a methyl group, the secondary amine is found to be more reactive than all the three amines. Therefore, the secondary amines would be more reactive. Now, the important point comes here. If R is a bulky group, okay, bulky group means ethyl group, two carbon atoms in ethyl group. Now, after the secondary carbon atom, you should give preference to the more bulkier group, that is there are three ethyl groups here. Therefore, the preference is given to the bulkier group after the secondary amine. Therefore, the tertiary amine will be in the second order of the basicity, and then the primary amines would be the less basic. Now, in the second condition, we have here the secondary amine being more basic. Now, if R is an ethyl group, okay. Now, if R is a smaller group, since smaller group as compared to that of ethyl group, the methyl group is a smaller group. Now, if R is a smaller group, then the second order of the preference is given to the smaller group after the secondary amine. Therefore, comparing the tertiary and the primary amine, comparing the tertiary and the primary amine is the smaller group. Therefore, the second preference is given to the primary amine. Therefore, primary amine will be in the middle, and then the tertiary amines will be the less reactive amine. Therefore, this is the comparison of the primary, secondary, and tertiary amines.